Assalamu alaikum. Today we are going to talk about part 2 of gastrointestinal tract development. Midgut and hindgut development. Now, these organs belong to the midgut: the duodenum, ileum, cecum appendix, ascending colon, hepatic flexure of the colon, and the transverse colon, only the proximal 2/3 of it. At about 5th week of the embryonic development, the midgut is suspended from the dorsal abdominal wall by a short mesentery. It communicates with the yolk sac by the way of vitelline duct or yolk stalk. This is the vitelline duct that connects between the yolk sac and the midgut. In the adult, the midgut begins immediately distal to the entrance of the bile duct into the duodenum, terminating at the junction of the proximal 2/3 of the transverse colon with the distal third. It is supplied by the superior mesenteric artery. This is the superior mesenteric artery. Development of the midgut is characterized by rapid elongation of the gut and its mesentery, resulting in the formation of primary intestinal loop. This is the intestinal loop. It has two ends, the cephalic end and the caudal end, and this is the point of meeting of these two loops. This is at the vitelline duct connect with it. The primary intestinal loop. At its apex, the loop remains open connection with the yolk sac by the way of the narrow vitelline duct. The cephalic limb of the loop develops into the distal part of the duodenum. This is the cephalic limb, gives duodenum, jejunum, and part of the ileum. Whereas the caudal limb, this is the caudal limb of the primary intestinal loop. It is the lower portion it gives the lower portion of the ileum, cecum, appendix, the ascending colon, and the proximal 2/3 of the transverse colon. Physiological umbilical hernia. This is a phenomenon seen or appears during the 6th week of development. The abdominal cavity temporarily becomes too small to contain all the intestinal loop, and they enter the extraembryonic cavity in the umbilical cord here. This occurs due to two reasons. First, rapid elongation, particularly of the cephalic limb, rapid growth and expansion of the liver. This is the liver. This results in a phenomenon known as the rotation of the midgut. Coincident with the growth in length, the primary intestinal loop rotates around an axis. This axis is formed by the superior mesenteric artery. When viewed from the front, this rotation is counterclockwise, and it amounts to approximately 270 degrees when it's complete. You can see this is the superior mesenteric artery. It represents the axis around which these loops will rotate. And here is the cephalic end, and this is the caudal end. Even during rotation, elongation of the small intestinal loop continue to grow, and the jejunum and ileum form a number of coiled loops. Here you can see these are the loopings of the jejunum and ileum. The large intestine likewise lengthens considerably but does not participate in the coiling phenomena. Rotation occurs during herniation, about 90 degrees rotation, as well as during the return of the intestinal loops into the abdominal cavity, remaining 100 degrees. You can see in this figure all this process is demonstrated. Here is the midgut loop, the direction of rotation about 90 degrees around the superior mesenteric artery represents the axis of rotation. Here you can see the small intestine, or here is the looping of this part during rotation, and here you can see the extending of this part outside or outside the abdominal cavity through the umbilical cord. Then retraction occurs and they retreat backward inside the abdominal cavity. They continue to elongate during all this process. Then they will settle down in its final position. During the 10th week, the herniated intestinal loops begin to return to the abdominal cavity. It is thought that the following play important roles in this retraction. First, regression of the mesonephric kidney. The mesonephric kidney is an embryonic organ that disappears in all mammalian species when the permanent kidney is functional, so it's a temporary structure. Then, reduced growth of the liver and expansion of the abdominal cavity. So these three reasons are helping in the retraction procedure. The proximal portion of the duodenum is the first part to re-enter the abdominal cavity. It comes to lie on the left side. The later returning loops gradually settle more and more to the right. The cecal bud, which appears at about 6th week, is a small conical dilation of the caudal limb of the primary intestinal loop, is the last part of the gut to re-enter the abdominal cavity. The cecal bud lies in the right upper quadrant directly below the right lobe of the liver. This is the cecal bud, and you can see this is the liver. From here, it descends into the right iliac fossa, placing the ascending colon and hepatic flexure on the right side of the abdominal cavity. This is the hepatic flexure, and this is the ascending colon. During this process, the distal end of the cecal bud forms narrow diverticulum. It is the appendix. Here is the appendix. Since the appendix develops during descent of the colon, its final position is frequently posterior to the cecum or colon, so it's either retrocecal or retrocolic respectively. In about 50% of cases, the appendix is retrocecal or retrocolic. Now, some congenital anomalies may result due to any disorder during development. Omphalocele is failure of the intestinal loops to turn to the body cavity after physiological herniation. The herniated loops are covered by amnion. They are usually associated with high rate of mortality and severe malformations as cardiac anomalies and neural tube defects. About 15% of the live-born infants, they have chromosomal abnormalities, so it's related to heredity. Abnormal rotation of the primary intestinal loop. The colon is on the left side, as you can see in this figure, and the small intestine loop are on the right. The ileum enters the cecum from the right. In figure B, the primary intestinal loop is rotated 90 degrees clockwise. Reversed rotation, the transverse colon passes behind the duodenum. This is the transverse colon, as you can see, and this is the duodenum. Here, the transverse colon settles behind the duodenum due to the wrong rotation, in the wrong reverse direction of the rotation of the intestinal loop. Now, atresia and stenosis. This may occur anywhere along the intestine. Mostly occur in the duodenum, fewest occur in the colon, and equal numbers occur in the duodenum and ileum. Most are caused by vascular accidents. Those in the upper duodenum may be caused by lack of recanalization. Now, the hindgut. The hindgut gives rise to the distal third of the transverse colon, the descending colon, sigmoid, rectum, and the upper part of the anal canal. Its endoderm also forms the internal lining of the bladder and urethra. The terminal portion of the hindgut enters into the posterior region of the cloaca, the primitive anorectal canal. The allantois enters into the anterior portion, the primitive urogenital sinus. This is the allantois. The cloaca itself is an endodermal lined cavity covered at its ventral boundary by surface ectoderm. This is the cloaca. This boundary between the endoderm and the ectoderm forms the cloacal membrane. Here you can see this is the cloacal membrane between ectoderm and the endoderm. Urorectal septum. A layer of mesoderm is the urorectal septum. This is the urorectal septum. It separates the region between the allantois and the hindgut. This septum is derived from the merging of the mesoderm covering the yolk sac and the surrounding the allantois. As the embryo grows and caudal folding continues, the tip of the urorectal septum comes to lie close to the cloacal membrane. This is the cloacal membrane. This is the cloacal membrane. Although the two structures never make contact. This is the urorectal septum and this is the membrane. They are close together. Rupturing of the cloacal membrane occurs at the end of the 7th week. The cloacal membrane ruptures, creating the anal opening for the hindgut and the ventral opening for the urogenital sinus. You can see this is the membrane. Then ruptures, and here creates two openings. One is for the urogenital sinus, the other is for the hindgut. Thank you for your listening.